All right, well, welcome to Math 105, Calculus 1. So this is the first quarter of calculus. We're going to have some fun this quarter learning about half of calculus, basically. Calculus is broken into two pieces. One's called differential calculus. The other one's called integral calculus. And we're going to do differential calculus. So that's what we're going to be learning this quarter. Before we get to calculus, though, I'm going to remind you about a bunch of things from algebra that are going to be really, really useful for us going forward. So today is going to be spent as a kind of a review of the entire year of pre-calc. So yeah, think about that. A year of pre-calc in about an hour and change. We're going to be going kind of fast, but I'm going to really target some of the more important things that are going to matter for us going forward. All right. But before we do that, I do want to talk a little bit about the syllabus and what to expect in this class. So I'm going to go ahead and share so you guys can see. So I'm going to go to our Canvas page, and we'll talk a little bit about it and what to expect. All right. So on the Canvas page, just so you can sort of see the orientation of everything. So we've got the syllabus. If you click on there, it's got a link to the syllabus, the class session link. You guys are in here, so you figured it out. Office hours, class Zoom, right? So all this stuff is pretty easy to navigate. And then we get into what's just called Calc 1. So this has all of the information that you're going to need. It's got links to the book. It's got links to other things that are on the web, and all our homework assignments and everything. Probably what you're going to be most interested in is just running over here where it says assignments. And this has a list of all of the assignments and also when they're due. So right now, if you felt so inclined, you could go in and bang out all the homework. Be done, not have to do anything the rest of this quarter except for when exams and quizzes pop up. All right, obviously I'm joking, but they're all here. So first of all, notice that all of the due dates, these are all Mondays. So all the homeworks are due Monday night. And I put here 11:59, so that's midnight, basically. But it's going to be midnight on Mondays. So you basically will have a week to complete all of the week's homework assignments. All right, so I do this to give you a little more flexibility. You don't have to worry about turning it around and getting it done, say, by Wednesday if life is getting in the way, right? So there's going to be a little bit on you to make sure that you get things done when they need to happen. But all the due dates are there. So you see, we got our homework set. Let me collapse this real fast. So then we also have quizzes. And so quizzes are going to be given on Fridays, not every Friday, but lots of the Fridays. And the way that those are going to work is I'm going to turn on this assignment. You'll notice it says here, it's not available until 8:30 on the 25th. So that's the start of class, right? So at 8:30, this will be available for you to go in. You'll see the quiz. You can take the quiz, right, just on your own paper. And then you need to upload a PDF of it. So hopefully you guys have something that can get a PDF. I know that there are a bunch of apps you can get for your phone. Maybe you have a scanner or something. But there's a way to upload it through the quiz. So like when you click on this, to actually see it, there is it will tell you how to upload the file. So those things on quizzes, those uploads need to happen by 9:10. Because basically after you're done with the quiz, then we're going to go right into lecture. So on quiz days, we are meeting. We're just going to do a quiz first. So basically think of it as I'm giving you 20, 25 minutes to take the quiz. and then an extra like 15 minutes to deal with any kind of technological issues. So it should be more than enough time, because quizzes are usually like 3, 4 questions. They're pretty small, but they're going to look a lot like what you did on the homework assignments. All right. Anyway, so the quizzes are going to happen, and we've got all those different dates. They're also on the syllabus schedule, but if they change, the dates change, I'll let you know. More often than not, one of the quizzes goes away. I decide not to do all 6, but we'll have them in there just in case. So then there are also 3 exams, and the exams work pretty much just like the quizzes. You notice that they're not available until the start of class on those various days. And same kind of deal. You're going to access Canvas, grab that exam, work on it, and then you need to upload a PDF of it by 11 o'clock. So again, basically I'm giving you 2 hours for the test and an extra half hour to deal with any kind of technology. All right, so those are going to be on those 3 days for sure. The only way that I'll change those is if we as a group all decide we need to change them because something else is going on. Like, doesn't usually happen this quarter, but like next quarter in calculus, a lot of you will be taking physics at the same time, and maybe you'll go, oh man, we got a physics test same day. Then I'll adjust it, but this quarter we're probably good. Anyway, so there are the exams. And then the final exam, same kind of story. It just shifted a little bit. According to the final exam schedule, we're supposed to start at 8. I have no problem bumping that back to 8:30, but we need to make sure that nobody has a final afterwards that's going to conflict. So we can talk about that later, because obviously that's not coming until December 7th. So we've got almost 3 months till that happens. So this is where you're going to want to access all of your assignments. To work on them, it's pretty easy. You just click on it, and it will bring you to My Open Math, which if you are familiar with our school, we use this for the pre-calc and things like that. If you've not seen this before, it's actually very similar to My Math Lab from Pearson and some other things like that. But basically you just hit start and it brings you to problems to work on, right? So for example, this one says we've got a polynomial. We want to find the y-intercept, the x-intercepts, and some other stuff. So let's just go ahead and do this real fast. So the y-intercept is going to be 0. And I'm curious. We're going to put this in actually as a point. Oh, no, it's an invalid use of comma. All right, so 0, let's see, the x-intercepts in order from smallest to largest are -2, 0, and 4. And let's see what else it is. When x goes to infinity, what's going to happen to y? Well, it's a cubic, so that's going to go to infinity. And when x goes to minus infinity, it also goes to, oh, it just says put minus or plus. All right, so we're going to check our answer. Yay, we got it, right? So we got 1 out of 1, and now we can go to the next question. So you basically just progress your way through. If at any point you're curious, you can click on this, says message instructor. It will send me a message and specifically tell me which problem you're looking at that you're having trouble with. So that's a really good way to get a hold of me if you have something specific from homework. All right, so I'm going to go ahead and submit and end. So I'm going to get a whopping 1 point because I didn't do the rest of them. But there you go. I got a score of 9.1% on them. All right, so that's basically how you do this. If at any point you're not happy with your score, you can just come up, oh, I just lost it here. You can click on this one that says retake and do it again, and then keep going until you get the highest score that you want. And so it always keeps your highest score. You'll get a list here of all your different attempts so you can kind of see, but basically keep going until you get a score that you want. All right, so that's how the homework works. It's pretty straightforward, not that big of a deal. The other thing I wanted to point out is that as this quarter goes along, I will be putting more and more things up, more handouts and resources. And all those files can be found here. If you look on the side where it says files. So we'll go ahead and click on that. And so right now, it's really boring. There's just the PDF of the syllabus, right? But as I said, there'll be more things that go there. So if you hear me mention in class, hey, I just put up this, a file of trig identities or whatever, this is where they're gonna be. And that just reminded me, I should probably put a trig identity sheet up there for you guys. So you can just click on it. It will pull it up and let you look at it. We'll go ahead and look at the syllabus here real quick and talk a little bit more about it and then start doing some math. All right, so first and foremost, best way to get a hold of me is to email me. You can use my college address if you want. It's armbrust@ltcc.edu. But this one's probably better because it actually goes to my phone. I have figured out, I've conveniently ignored how to put my work email to my phone. So this is a little bit better. I will get back to you within 24 hours, with the exception possibly of weekends and holidays, because I may be doing other things. While we're at it, I prefer to be called Bruce. I'm really informal. I think it helps if we just sort of can knock down that teacher up here kind of thing, because I'm not a god. I'm not I'm pretty close to a math god, but I'm not quite there. So I'm just a regular person. So I like to be called Bruce. If that's weird for you, that's fine. You can call me whatever, whatever's best for you. So then office hours. So office hours, of course, those are the times that you can work with me one-on-one if you have specific questions, usually about the class, but it can be about other stuff. I know, Lord, I've talked about what classes should I take for my major? Should I maybe change my major? Sometimes it's, I lost my job, I need to talk to someone. I'm really open to just chatting. And I know, especially now in this kind of weird COVID world, we don't really get interaction all that much. So use me for that as well if you need. But these are times for sure that you'll find me. There's the Zoom link. It's also available through the Canvas site, so you don't have to go to the syllabus. But it's a different Zoom room, right? So you can just come there. But you'll see that I'm there from 11 to 12, Monday through Wednesday, and then 10 to 12 on Thursday. The only reason I'm not doing one on Friday is because I have a recurring meeting at that time between my classes, so I don't really have time on Fridays. But if these times don't work for you, or you just need something different, let me know. And I'm more than happy to work with you to find a different time, as long as it doesn't interfere with my classes or whatever else I got going on. I'll be happy to meet with you. All right, so that's how you can find me to chat. The textbook, it is a free textbook. It's OpenStax is a kind of a new nationwide initiative trying to make textbooks that are available and for free or low cost. And just so you know, all calculus books are about the same. They really are. They're very slight differences. So if this one's not working for you and you find an older edition of some other textbook for cheap, grab it. It'll be very, very similar. And I don't exactly teach from the text. I use it as a guide of what I need to talk about, but I talk about calculus from Bruce's perspective, which is going to be a little bit different, but still the same. So that's the textbook. In terms of calculator, like Susanna was asking earlier, it doesn't really matter what you have, but it's going to be handy. And it's going to be really useful. There are also a lot of good places on the internet to do calculations. I know one of the real popular ones is Symbolab. Desmos is a really good one for graphing. There's Wolfram Alpha, a whole bunch of places like that. Those are also really good resources. Just make sure that you still know how to do it on your own, not just how to type it in. I'll talk a little bit more about that in a minute. Anyway, so the course description, we're doing calculus. You'll understand what all those different things mean when we get there. All right, so the student learning outcomes, that's just what we expect you to be able to do by the end of this class. Again, it'll make more sense once we get there. So course grade, I already kind of talked about the assignments, but this is how it's going to break down in terms of your overall grade. So homeworks are worth 15%, quizzes are worth 20%, the 3 exams total are 40%, and then the final, which is cumulative, but you're probably already used to that in math a little bit. All of math is cumulative. We're going to be using things that you learned 5 years ago in some basic algebra class at some point, right? So it just all kinds of builds. But anyway, so the homework, you already saw that they're due Monday at midnight. But one thing I didn't mention, and this is kind of big, it's down here at the bottom, the last sentence, right? It says, if all homework is completed with a score of at least 50%, your lowest regular exam score will be dropped. Okay, so do your homework, right? Get at least 50% on everything, and I will drop your lowest exam score. That can only help, right? It cannot hurt you because everything's based on a weighted average. So basically, that gives you an out for one of the exams. You have a bad day and that test goes horribly, oh well, no big deal. You took, did all your homeworks, 50%, it's gone. All right, so do your homework. With the quizzes, I will drop your lowest quiz score. You notice right here in the middle, your lowest quiz score will be dropped. So no matter what, you guys all get a dropped quiz score. So same deal. You have a bad quiz, not the end of the world. You have 2 bad quizzes, we need to start talking, right? But 1 bad quiz score, not that terrible, all right? But because I do drop low quizzes, I don't let you make any up. So if you miss it, you miss it. Right? The exams, like I said, I mean, they're basically their take home, open book. Those, if something happens and you need to adjust the time date, or the exam date, just let me know, and I'm happy to work with you a little bit. Like if you notice on one of those days, oh man, I've got a doctor's appointment, blah, blah, blah. I get that, and I'll be happy to work with you. The registration info there is just so you got it. Basically the drop days. You can drop with no record by September 25th. After that, you're going to get a W until November 6th. But then after that, you will get a grade of some type. So that's just there for your reference. How to succeed in math. You guys at this point know how to do this, but real quick, come to class. Seems obvious, but it's going to happen. You don't come. If you don't come, at least watch the video. And I've got a YouTube channel, like I explained in the syllabus here. Also, there's the link to it in the Canvas. So watch them. It's better if you're here because you can ask me the questions and I can answer you directly. But if something comes up, at least watch the video. Okay, do the homework. Again, seems like a no-brainer because it's worth 15%. But remember, you also get to drop an exam. So do the homeworks. If you find you need more practice than the homework's giving you, do it, right? Do more. Read the book. That one's a tough one because most of us don't like reading textbooks. But like I told you, I don't teach from the book. So reading the textbook might give you some ideas or a different way of thinking about it that works for you better. Okay, so read the book. Make use of tutors and my office hours. All right, so I already told you how to get my office hours. But math tutors, we've got math tutors in the library. And so I put the link here. If you go to ltcc.craniumcafe.com, that'll bring you to the library. And through there, you can find the tutors. All right. And those are your fellow students. Many of them have taken calculus with me. So they know this material, they know what I expect. They're a really good resource. And then this fifth one is do a little math every day. Not a ton, but a little bit, just to keep it fresh, right? If you don't do it for a while, you lose it. And I don't know if any of you are students who are coming back from not being students for a while. But if you leave for a couple of years and then come back, it's really tough. It's the same thing if you leave it for a week, it can be tough to come back. So then just some more information here for you guys. If you work through the DRC, please get a hold of them and let me know as soon as possible what I can do to help you with accommodations. Also, I just gave you the link to the library itself. I want you to realize that it's not just tutoring, but you can, like I say here, request textbooks, get research help, borrow Chromebooks, and so on. So, and I put the hours there for you, just so that you know. And they did say that math tutoring is available during all of those hours. Okay, so if you run into any issues with the math tutors, please let the library know. And also you can let me know, like if they're not showing up or are not helpful or whatnot. So the last thing I just want to bring up here when I put up here, academic dishonesty. This is something that is a little bit harder for me to police, obviously, the way that we are doing things. But basically, don't cheat. And for you guys, because most people don't take calculus just because, right? This isn't the kind of class that it's checking a box. You just got to take it and be done with it. You guys are taking this for a reason. You're going to be science majors, engineers, computer scientists, something like that. And I promise you that calculus is necessary to do those subjects. And so if you kind of limp your way through this and you cheat your way through this, you're going to make it way harder for yourself later. I know, typical old man telling you about back in my day. No, but I promise you, it is one of those things that if you don't have a good foundation, it's going to hurt later. And you've probably seen that in math, right? When you took trig and your algebra was weak and you went, oh my God, trig is so hard because you don't have the algebra skills. Well, calculus is going to be tough if you don't have the algebra and the trig. And then your next classes are going to be tough if you don't have the calculus. So make sure you know how to do it yourself. So I put on here, on exams and stuff, cheating does include using those online resources, right? So like if you just type into Symbolab, solve this, differentiate this, and they give you the steps, that's cheating. It's no different than asking the person next to you, how do you do this problem, right? And you need to know that I can tell I can tell when you've used one of these things because they don't do it like humans. They don't. They're machines. And you can tell the difference if you know what you're looking for. So just don't do it. Don't do it. All right. Do your best on these things and realize that all exams and quizzes are a way for both of us, both you guys and me, to see where you are, see what we need to work on, and how to get you to that point where you'll be ready when you move on to physics, when you move on to your statics class in engineering or what have you. All right, so don't do it. It's not worth it. And then here's our schedule. So I put here, it's very tentative. It probably will change, but that's our schedule. So you'll notice that chapter 1, I've got it for today. It'll probably spill a little into Wednesday. But basically, like I said, this is going to be the high points of pre-calc, just to kind of get you ready. But then we're just going to march right through this text. We're going chapter 1, 2, 3, and then 4, right? So all the exams and quizzes are on there. I did build in a day of review before each exam. So those are kind of our, also gives us a little adjustment if we need to, if we find a certain section takes us longer than another. But a couple other things I want to point out. Notice that on November 9th, which is a Monday, we will not be having class because that is Veterans Day. Well, it's not Veterans Day. Veterans Day is the 11th, but we're celebrating on the 9th. So we won't have class. When we get closer to that point, I'll remind you, but basically you get a day off of Zoom. And then the entire week of Thanksgiving, so November 23rd through 27th, there will not be class. Okay, so on those days, we'll be off as well. So we'll have an exam the Friday before, and then we'll come back and we'll have one more week before finals. Okay. So there's everything. And in terms of how this class breaks down, basically in chapter 2, I'm going to introduce you to calculus. Right? I'm going to tell you like what it is and how it works. In chapter 3, we're going to learn about the derivative, which is the key of differential calculus. So we'll learn the different rules and how we differentiate things, what it actually means. And then in chapter 4, we're going to learn how to use the derivative, like what it's good for. So it's kind of a nice progression. We start with, what is this thing? Then we go to, how do we do it? And then we go to the, why do we do it? Which is, I think, pretty good, especially when you're learning something new, especially that last part, the why do we care about this? And you're going to see calculus has all kinds of uses, things that you might never expect. Anyway. All right, so any questions on the syllabus or what to expect coming out of this quarter? All right, looks like we're good. So let me stop sharing. All righty, so let me go ahead and move up to the whiteboard here. Let me just take care of something that just fell. All right, so let's talk a little bit about pre-calc, all the things that you missed that are super important, or hopefully you got them. I just want to remind you of what we're doing. And so, first of all, super, super important are functions. All right, so I want to find out from you guys, what do you remember about functions? And I'll take anything you remember.
For each x, just one y.
Okay, for each x, just one y. I love that, Susanna. That's perfect. So the big thing about functions is that for it to be a function, it's a rule. It's a rule of assignment. And basically what it says is for everything that we put into it, we can only get one thing out. So let me remind you what the notation looks like. Right, so we got f of x. So f is the name of the function. X is what we're putting in. And then there's usually some kind of a rule. And what's really important, like Susanna said, is that there is no option for what comes out. Okay, we only get one thing. So I like to think of it as there is no or. There's never an or. For a function, you put something in, you get one element. There is no choice. It's this and this alone. Okay, so that's kind of important. Remember that we only get the one thing out. Okay, so what do we call the set of stuff that we put in? Do you remember the name we use for that? All right, hearing.
X-intercepts?
Okay, so X-intercepts are where we cross the x-axis on the graph. But the set of things that we put in is what we call the domain. So the domain, this is the set of inputs. So all of the things that we put in, that as a group are what we call the domain. So what do we call the things that come out? There it is, Mario's range. This is one of those things that as soon as I tell you domain, everybody goes, oh, I know what the next thing is. Because domain and range always go together, right? So the range, this is the set of outputs. So we're going to talk about this a lot. When we talk about functions, the domain is super important. Specifically, the range is also useful for lots of situations. Okay, so just remember domain and range. The domain is the stuff that we put in, and the range is the stuff that comes out. So think of the domain as your x values, and the range is your y. But I want to be a little bit careful here, because I know we're really used to x's and y's, but we're going to use all sorts of variables to represent our domain and our range. It's going to kind of depend on what the situation is. So we got to watch out for that. But in general, we think of them as x and y. But it could be t's, it could be thetas, it could be who knows what. All right, what else do you remember about functions? And I know it's kind of a big concept. I mean,
Horizontal line test.
Okay, so cool, vertical line test. Let's talk about that. So when we graph, remember that when we graph, we've got our x and our y axes. So the x-axis is containing all of the domain elements, and the y-axis is holding all of our range elements. And so in order to be a function, if we were to draw something like this, remember what it says, or what we said about functions, is that for everything we plug in, for every x, there's only one y. So that tells us that if we were to draw a vertical line, And I know this is probably a little bit light on your screen. That's okay, I want to differentiate it from the other thing. Notice that it only intersects at one place. If it were to cross in more than one place, like let's say this was our graph, this would fail to be a function because for this one x, we have a choice of two different y's. So that's why the vertical line test works, but it's actually a really easy way of visually checking if you've got a function or not. Okay, cool. So vertical line test. There's also a horizontal line test that we'll bring up in a little bit. But let me erase this so that it is a function again. All right, so here's a function. So some other points that matter on this graph are the intercepts. So let me draw those dots right here. And I know that earlier, I think it was Susanna said something about X-Intercept when I was talking about domain. So X-Intercept, this is a place where we cross the X-axis. So if you were to look at the graph, it's where we cross the X-axis. Intercept is where we cross the Y-axis. So do you remember how to find those? Like obviously on a picture, it's easy to tell. But like if I just gave you the function and its rule, do you remember how to find the intercepts?
You make the other point 0.
Yeah, you set something equal to 0. So for the y-intercept, what you do is you set x equal to 0, because that's the x-coordinate on the y-axis. So you plug in x equals 0, and you actually just see what you get out. And then for the x-intercept, it's similar, except you let y equal 0. Now, there's not always a y though, right? Like if you think about it, let me give you a function here. Like let's say f of x equals x squared minus x. So we'll go ahead and find the intercepts for this thing. So if we start with the y-intercept, we're going to set x equal to 0. So we'll plug 0 into our function. So we get 0 squared minus 0, which is 0. So that one, I know it's actually going to go through the origin, right? So we've got an intercept of 0, 0. This is another thing that I try to do is write my intercepts as points. Because they are points, it's important to know both the x and the y. So when I do a y-intercept, I'll actually write the entire point 0, 0. But now let's look at the x-intercept. So again, remember what we want to do is we want to set the y equal to 0. But if you look at this, there is no y, right? There's not a single y in what we wrote up here. But the f of x, that is the y. And the y is what comes out. So we're really taking this x squared minus x, and we'll set it equal to 0. So x-intercepts are always harder to find, but no, it is what it is. So for this one, we would factor. So I get x times x minus 1. And so we actually get two options here. There's x equals 0 and x equals 1. So it turns out that there are two x-intercepts. One of them is 0, 0. That's the same one that we saw before with the y-intercept. But the other one is 1, 0. So this one actually crosses the x-axis twice. But I bet a lot of you can see why that is. Anybody recognize what kind of graph this is?
Parabola.
Yeah, it's a parabola. It's a quadratic. So it's a parabola. It's a happy parabola, right? It's got the positive a, so it opens upward. So you can imagine that a smile crossing the x-intercept twice. Yeah, sure, that happens. Okay, so there's a little bit more about the graphs and some things that we look at. So the important points are x-intercepts and y-intercepts, and of course using the vertical line test to see whether or not they actually are functions. So another thing that we can do with functions is we can do operations on them, just like with numbers. You can add, subtract, multiply, and divide. So let me just remind you about those real fast. These are almost silly because they are so easy. So let me give you two functions here. Let's say f of x is x squared. And let's say g of x is about natural log of x. Just to have some functions here. So you can do the operations like adding. So you'll see f plus g of x means we want to add these together. And we literally take those two rules and we add them together. Ooh. All right, subtracting, same deal. You'll see f minus g. And again, it literally is. Subtract the rules. We have multiplication. So f times g. We use the dot, not the x times, because then it might be thought of as the variable, but we can do f times g. So this would be x squared times natural log of x. And then we can have division. And again, it looks exactly like we think. And so we would have x squared over natural log of x. So this is why I said it's kind of silly, because it's exactly what you think you should do. But it's important to remember that these operations work for things that are not just numbers. And as you go further in math, you're going to run into things, more and more things, types of things in math. There is one thing I do want to mention about the division, and this is not going to surprise anybody. What do you have to worry about with division? What's the ultimate danger? All right, cool. Yeah, you can't divide by 0. All right, thanks, Chase. So when we do division, it's understood that this denominator, the bottom, can never equal 0. So we would have an issue potentially with division, but in this case we don't, because natural log never actually equals 0. Okay, so there are the 4 basic operations, but there's one more. And this one is unique to functions, and it's composition. And this is the one that you'll see written in 2 different ways. One is with what I call fog notation. Right, so this is, it's not an O, but it's just an open circle. And so this is f of g of x. Another way of, you'll see it written is like this. And this is what I will write. I'm not a big fog guy. I'll write it this way. And basically what we're doing here is we're taking one function and we're putting it into the other function. Okay, so this would be f of g. We could similarly have, say, g of f. Right? You can actually compose a function with itself. You could have f of f or what have you, but this is a different operation that we can do with functions. So let me show you how these work with the functions that I gave you. And you probably saw a picture like this. I like to think of functions as machines. Okay, so like let's say that this is the function g. And then what we're going to do is we're going to attach a function f. And so if we were to do, say, f of g of 1, let's say. So what this tells us is that we're taking 1 and we're plugging it into g. These are read backwards. They're read from right to left. What you'll hear me say is we're doing it from inside out, because I think what's inside the parentheses. 1 is the most inside, then the next most inside is g. So we're going 1 into g, and then into f. So we're working our way out. But we're going to put 1 into g, and g does its thing. So in this case, g of 1 is the natural log of 1. Does anybody remember what that is?
Is it 0?
It is 0. No matter what kind of log you've got, if you plug in 0, you get 1. Or sorry, you plug in 1, you get 0. Okay, so this 1 got turned into a 0. And now that 0 gets put into f. So we're going to do f of 0, which is 0 squared, which is 0. So in this case, f of g of 1 is actually equal to 0. All right, so that's how function composition works. We're actually going into these functions in order, and what comes out of one goes into the next. So it's just a series of functions, and we just sort of follow it along. Now that's what you do if you put in a specific value. Sometimes you don't. Like we could have, say, let's just do g of f of x. So for these specific ones, what we're going to do is we're going to start with f, which is x squared, and we're going to put that into g. So this is going to equal the natural log of x squared. So we took this entire rule and we put it into g. So in this case, g of f of x is equal to the natural log of x squared. If we did it the other way, this one's going to equal the natural log of x and that whole thing being squared, because now we're taking the rule natural log, we're taking the g, and we're putting it into f. So that's how composition works. This one's just a little bit more complicated because you got to pay a little more attention and you're not used to it. You've been adding things since you were like 7. You've been composing things for like 2 years, right? So you're just not quite familiar with it yet. But we'll do this a lot. And it's important to recognize composition when we're doing some certain calculus steps. So you'll get really familiar with it if you're still uncomfortable. All right, so is that kind of a good little reminder of composition? Good. All right, So let's talk about some properties of functions. Some characteristics, some things that we look at that some functions have and others don't. And again, these are going to be useful with calculus. So how about we start here? Some functions are what we call increasing. And increasing should make sense because we think about what that word means when we just say it. Increasing things are getting bigger, and that's exactly what it means for a function. Okay, it says that a function is increasing if, I'm going to give you the mathy way of doing it. We say if x1 is bigger than x2, then f of x1 is greater than f of x2. Okay, so this is how a mathematician would say that a function is increasing. For us, this just means it gets bigger. And I'm going to put here as you go to the right. All right, so this is increasing if it gets bigger as it goes to the right. All right, so basically you know what I'm talking about. Here's an example of an increasing function. As you move to the right, you're getting bigger. You're going up. And that's exactly what this says. So think about this. x1 and x2, those are just two different x values. Remember the subscripts, we use that to designate things that are similar, but still different. All right, so x1 is greater than x2. That means that it's somewhere to the right. So this would be, say, x2, and there's x1, right? So if x1 is bigger than x2, if x1 is to the right, then f of x1 is bigger than f of x2. And remember that those f's, those are the y values. So if f of x1 is bigger than f of x2, that means that this is higher than f of x2. So as we went to the right, we went up. So this is the mathy way of saying exactly what we want, which is it gets bigger as you go to the right. If you're not really familiar with this part of mathematicians yet, you should be. We tend to try to complicate things. Now, no, let me put it this way. We try to simplify stuff. We try to simplify, have real specific ways of saying it, but in the process of simplifying, we make things really complicated. And that's what this is. This is writing, instead of the words, hey, it gets bigger as you go to the right. This is in without words. Nice and simple, nice and clear to a mathematician, right? You give this to anybody else and they're like, what the hell are you talking about, right? So we tend to do this a lot. By simplifying, we complicate. But when you get familiar with the language of math, you start seeing how this is simpler and more elegant, and that will come as you guys go. Well, anyway, so that's increasing. So then, of course, decreasing, same story. We're just getting smaller as we go to the right. So instead of saying bigger, we're going to say get smaller. And so we can change this definition ever so slightly by changing the direction of an inequality. But I want to make very clear I only changed one of the inequalities. The first one I left alone. It still says x1 is greater than x2, because I still want to be talking about going to the right. But now I'm saying that that y is smaller. So we're going down as we go to the right. So I just put here get smaller as we go to the right. So again, the mathy definition is this stuff with inequalities. But in words, it just gets smaller as we go to the right. So some functions are increasing, some are decreasing. Like I'm sure you can think of functions that you've seen in the past that do one or the other. There are also functions that are not increasing and decreasing. They can be constant. You can have some that increase and then decrease. Right, so there are all kinds of different varieties. But this is what it means to be increasing and decreasing. And this will be a big deal for us in chapter 3, I think, maybe chapter 4. We'll talk a lot about how we can use calculus to figure out when functions are increasing or decreasing. Okay, so increasing and decreasing. Another thing that we talk a lot about is symmetry. And specifically with functions, we look at two different types of symmetry. One is symmetry, so I put here symmetric over the y-axis. So we treat the y-axis like a mirror. And the other one is symmetric about the origin. So these are the two kinds of symmetry that we're going to be looking at when we talk about functions. All right, so let's first talk about the one that's symmetric over the y-axis. So a great example of that, one that you all know and love probably, is good old f of x equals x squared. See if I can actually make it look symmetric. So this is a function that has the first kind of symmetry. Again, imagine that the y-axis was a mirror. We see the reflection of one side on the other side. There are a lot of functions that have this. Cosine, absolute value of x. Again, tons and tons. So we call this one symmetric over the y-axis. And the name that we use to describe this is what we call an even function. And that name, even, comes from the power functions. Like if you have x to a power, if that exponent is even, you get this kind of symmetry. So x squared, x to the fourth, x to the sixth, x to the eighth, so on. All right, now, the term even is awesome because it's nice and short and concise and we know exactly what we're talking about. But the way that we would actually describe this mathematically is we'd say that f of negative x equals f of x. So just like with increasing and decreasing, we can be mathy about it. We can do the same thing here. So with even functions, negative x and x give you the same y value. Okay, that's all this is saying. So think about what x and minus x are. Those are 2 points. They're the same distance away from 0. They're just on opposite sides. And you put either of those in, and you get the same y value. So somewhere out here is negative x, there's positive x. Right? And so if you look at those two y's are the same. And so for an even function, this is true no matter what. And so that's how you can actually check for evenness, is you just plug in negative x and see if you get the same thing that you started with. And you can see that why that works here. Because if we were to do this with x squared, f of negative x would be negative x squared. And I'm sure you all remember that when you square a negative, it ends up being positive. And so we end up with exactly the same rule as we did when we started. All right, so that's that kind of symmetry. Symmetric over the y-axis, we call it even, and that's our check. So let's look at symmetric about the origin. Now the origin is just a point, it's not a line, so we don't have a mirror anymore. But what we now have is what I like to call rotational symmetry. Like, let's look at this one. So this is no longer even. This is what we call odd. Again, comes from the fact that if we're talking about power functions, x to a power, if that power is odd, then these things have this symmetry. But here's how I like to think about it, is if I were to rotate it halfway around, it's a little bit hard for me to pick up my whiteboard and turn it, but you can imagine if I had this on a piece of paper. In fact, let's not imagine. Let's do it. I don't know if you can see it. I'll bring it in a little bit closer. Okay, so same function. So what I'm going to do is I'm going to rotate it halfway around. It looks exactly the same, right? I flash this up, or I flash that up. You wouldn't know the difference, right? So that's odd symmetry. So I think of it as a rotation. You can also think of it as a double flip. If you were to flip it over the x-axis and then the y-axis, or y-axis and then x, you get the same thing. I find that way too confusing. I prefer just rotating half a turn. Okay, so if you can rotate it half of a turn, then it's an odd function. And that's what we call symmetry about the origin. All right, so the way that we check this is similar. We're still going to plug in a negative x. But now instead of getting the same thing that we started with, we get the opposite of it. We get the negative. So basically what this is saying now is that if we were to pick two different x values, so the positive x and the negative x, and we were to look at those y's, what we see is that they're the same y, but just with different signs. And that's exactly what this statement is saying. If you put in the negative, you get the opposite y value. So for both even and odd, all we have to do is plug in negative x and see what happens. If we get what we started with, it's an even function. If we get the opposite of what we started with, it's an odd function. If we get something different, it's neither. Because there are plenty of functions that are not odd or even. Think about natural log of x, for example. That one's neither. So we'll see that when we plug things in. So let me give you another example, just so you can kind of see how we could check this out. We'll do a couple. Let's look at f of x equaling x cubed minus x. So we're going to test this for symmetry. So let's plug in negative x. That's going to be negative x quantity cubed minus negative x. All right, so the negative, when we cube it, stays negative. Subtracting a negative is the same as adding. So notice that what we get is negative x cubed plus x. And if you compare that to the original function, notice that all of the signs are different. So like if I were to factor out the negative, I get negative x cubed minus x. So that's negative f of x. So that tells me right now that this guy is odd. It's an odd function because when I plug in the negative number, I get the opposite of what we started with. So I didn't have to draw the graph, but I know right away that it's odd. So if I started to plot points to try to get a feel for what this graph looked like, really I only had to draw half of it. I could draw just stuff on the right side because I just changed the signs and moved to the left. Okay, so those are the symmetries that we're going to look for functions. Sometimes people ask me, how come we don't look for symmetry over the x-axis? Right, because when we did that symmetry, the first one was over the y. Why not symmetry over the x? Can anybody tell me why we don't worry about that? Because basically what that would say is, let's say we've got something on the top, we'd want the mirror image on the bottom. So this would be symmetry over the x-axis. So why don't we care about that?
It's not important to tell if it's like a function.
Yeah, well, now it's not a function. Right?
Yeah,
the vertical line test. This thing fails to be a function. And if you think about it, kind of by definition, if we've got this symmetry over the x-axis, it says that for this x, we're going to get two different y's, one positive, one negative. No, that's not a function anymore. So if we're going to talk functions, we don't care about the symmetry. If we're not concerned about it being a function, we can easily have the symmetry, right? I can draw this parabola on its side and have this kind of symmetry, but it's no longer a function, so that's why we don't care about it. All right, so there's a little bit about symmetry. You've probably heard those terms, even and odd. This is just more formalized, probably. And I'm also trying to get you used to the way mathematicians write and the symbolism that we use. So that's why you're going to see me write things like f of negative x equals f of x, just to start training you to think right. All right, so there are just some properties. One more property, actually, while we're at it, is one-to-one. So let's just talk about this real fast. So one-to-one functions. We don't usually write it out one-to-one. These are the ones that you'll see written as 1-1. So it's not 1 minus 1. It's 1 to 1. And 1 to 1 functions, anyone remember what those are? All right, so hearing nothing, and thanks for the honesty there, Chase. You just put in the chat, no. So 1 to 1 functions, these are ones where every y comes from only one x. So this is sort of similar to the definition of a function. Remember, for a function, it was for every y, or for every x, there's only one y. Now this is every one y, there's only one x. So it's called 1 to 1 because every x is paired with a specific y. Every y is paired with a specific x. Okay, so in math speak, what this says is if f of x1 equals f of x2, then x1 equals x2. So two different y's. If those y's are equal, then the x's were the same. So this is the real mathy way of saying it. This is the more just English way of saying it. In terms of the graphs, this is where we use the horizontal line test. And it basically works the same way as the vertical line test. So think about this one right here. This is definitely a function. You take any vertical line, it intersects it only one place. Now, if we take the horizontal lines, you'll see that horizontal lines can intersect more than once. And again, I know that's a little bit lighter, but that's intentional here. But think about this right here. These 3 points all have the same y, but they're coming from multiple x's, so it fails being 1 to 1, right? 1 to 1 says every y comes from only one x. So you can use the horizontal line test just like the vertical line test. So you just go, all right, draw a horizontal line, intersects more than once, not 1 to 1. But if every horizontal line intersects only once, then it is 1 to 1. So let me draw an example of one that is 1 to 1. A good example that you guys know would be, say, an exponential function. This thing is going to be 1 to 1 because any horizontal line is only ever going to intersect it in one place. There is no turnaround, right? There's no turnaround vertically. All right, so 1 to 1, that's another important property that we're going to see later matters quite a bit. All right, so there's 1 to 1. How about at this point, we just talk about some of the types of functions. I'm going to call this the library of functions, meaning these are functions that you should know well, like domain, range, graph, increasing, decreasing. Like you should know just about everything about these. All right, so let's start with constant functions. So an example would be like f of x equals 2. Not 2x, just 2. All right, so what do these things look like? All right, cool, thanks, Mariola. She just said it's a horizontal line. So if this is our x-axis, that's our y-axis. F of x equals 2 just says no matter what you plug in, you always get out 2. So here are a whole bunch of points, different x's that give us a y of 2. You do this enough, and eventually you just see horizontal line. Okay, so they're horizontal lines in terms of domain and range. Their domain is everything. So we have all real numbers. And then the range is really boring. It's just whatever that constant is. So in this case, the range is 2. If it was a function f of x equals, say, -5, its range would be -5. All right, so it's constant. It's called a constant function because we always get the same thing out. So it's not decreasing. It's not increasing. Is it even or odd or neither? All right, good. It's even. What's that? There it is. So this is an even function because it's got that symmetry over the y-axis. It was kind of a trick question, though. If this is equal to 0, then it's both even and odd. But that's a weird case. Okay, so there's your constant function. Another set, if we kind of just bump it up in that notch, are linear functions. So these are the guys that are f of x equals mx plus b. So you know all about those. So some things to remember. In terms of the domain, it's all real numbers, as is the range. These things, you can plug anything in. You can also get anything out. So the domain and range are all real numbers. All right, now, what about the other properties? Are these increasing? Are they decreasing? All right, so Mariola just said it could be either, either or, and that's good. It's yes. Are they increasing? Sometimes. Are they decreasing? Sometimes. But no matter what, they are either increasing or decreasing. What tells you whether it increases or decreases?
The slope.
Yep, exactly. The slope determines everything in terms of this being increasing or decreasing. So we're going to continue the linear talk over here. So if m is greater than 0, it's increasing. And if m is less than 0, it's decreasing. And hopefully you remember that. Slope is really telling you the direction that these things go. Remember, b is your intercept, it's your y-intercept, so where you cross the axis. And then the slope just tells you which direction to go. Positive slope means you're going up to the right. Negative slope, you're going down to the right. And so for these, increasing or decreasing is solely determined by the slope. It doesn't matter what the y-intercept is. It can be absolutely anything. But the slope tells you everything in terms of increasing and decreasing. All right, how about even and odd? Is it even, odd, or neither?
I would say neither, just because you don't have an exponent right now in your function.
Okay. And then I also see, is that from Erez, that it can be odd, but with a question mark. Okay, so here's the deal. It depends. Just like increasing, decreasing, even or odd, or neither, it depends on the function itself, like which line we happen to have. And for this one, it all comes down to b. So the slope told us about increasing or decreasing. The b, the intercept, tells us even, odd, or neither. So if b does not equal 0, so that means that we cross the axis somewhere other than the origin, it's neither even nor odd. Okay, so it's just going to be no. It's not even, it's not odd. Okay, so then if b equals 0, so we actually go through the origin, then it's an odd. So lines are another one that are a little tricky, but in terms of even or odd, it's odd if it goes through the origin, and if it doesn't, it's neither even nor odd. Okay, so these things matter, the slope and the intercept. Hopefully you're pretty good with lines. Make sure you review a little bit of how to find slope, how to graph them, and that kind of stuff. So correct, Erez just said it can never be even, and that is correct. Lines are never even, which should make sense, because if you think about even, you'd have to have some sort of a turnaround, and lines don't do that. Lines just continue going in whatever direction they're going forever. They never turn around. All right, cool. So there's lines. Real quick, before we move off of linear functions, I want to remind you of another form for the equation of the line. So you guys are used to this one, probably. Y equals mx plus b. We call this the slope-intercept form. And mathematicians, of course, name everything exactly what they are. This is the form where if you know the slope and the intercept, you got it. But there's another one that we call the point slope form that is a little bit more useful. So I just want to remind you of that one. That's the one that looks like y minus y1 equals m times x minus x1. So this is the point slope form. Because if you know a point, x1 and y1, and you know the slope, m, you're good enough. Okay, so there's your point slope form. We'll use this a lot from time to time, but I just wanted to remind you about it. So put it back up in your brain. All right, so the next set of functions that are kind of useful are the quadratics. So I think this is number 3 on our list. So these are the ones that can be written f of x equals ax squared plus bx plus c. All right, so their graphs are all parabolas. So a couple of things to help you if you want to get a real quick graph of the parabola. Some features that we know from this. Okay, the y-intercept is super easy to spot. It's just 0c. So whatever the constant is at the end, that's your y-intercept. In terms of its orientation, whether it opens up or down, and in Bruce speak, they're happy and sad. I think I mentioned this before. And the way to tell is just by looking at A. If A is greater than 0, so if that lead coefficient is positive, it's a happy parabola. It's a smile, because positive people smile, right? And if A is less than 0, if it's negative, it's going to be oriented downward, so it's going to be a frown, because negative people frown. Okay, so get used to that too. If I say happy and sad, it's just my way of opening up or down. So you get the orientation, super easy. And then the other thing that you can get pretty quickly is the vertex. So the vertex, that's the turnaround point. So those places are kind of important with parabolas. And the easy way to get the vertex is to look at negative b over 2a, and that'll get you the x coordinate. You can then get the y coordinate by plugging that in. So this will get you all the important information if you want to draw its graph. It's pretty quick and easy. So let's just talk real quick about domain, range, all that good stuff. So in terms of its domain, the domain is all real numbers. You can put anything you want into any polynomial or any quadratic. Now, the range is a little bit more difficult. It's either negative infinity to, let me use a different number, we'll call it D, or D to infinity, where D is the y coordinate of the vertex. Right, the vertex is the turning around point. So if it's a sad parabola, think about this bottom one I drew over here, its domain is going to be from minus infinity all the way up to the vertex. So that's what I wrote here, minus infinity, comma D. If it's a happy parabola, its lowest point is the vertex, and then goes up forever. So that's why I wrote here, D to infinity. So this one's a little bit more difficult in terms of finding the range, but you can spot its orientation right away, so you know which of these it is. And then you can just find that y coordinate of the vertex, and you're good to go. In terms of the intercepts, like I told you, the y-intercept is easy. You just look at C. For the x-intercepts, there's a really fast way of determining how many there are. And that's by looking at what we call the discriminant. Hopefully you remember the quadratic formula. If you don't, I'm going to go ahead and put it up here. Get to know it. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, the part that's inside the radical, so this guy right here, the b squared minus 4ac, it's what we call the discriminant. And this thing tells you exactly how many intercepts you're going to get. If this is greater than 0, you have 2 X-intercepts. If it's equal to 0, you get 1 X-intercept. And if it's less than 0, you don't have any. So it's kind of nice. The reason that this works is because of the square root, right? If the square root is negative, you can't have any intercepts because the square root of negative is a complex number. If it equals 0, all that stuff goes away after the plus and minus, so you don't have any choices anymore. You just get 1. And if it's positive, the square root of that number exists. And so you add or subtract, which means you get your 2. And the other cool thing about this is that if it is just the 1 X-intercept, it's the vertex. So if you're in that situation, your 1 X-intercept is the vertex. So think about that when that discriminant is 0, that square root goes away, and what you're left with is just negative b over 2a, which was the formula for finding the vertex. All right, so there's the quadratic. So let me just show you something here real quick. And it's probably, you can't even see that at all, it's all bled out. I have an entire page of stuff I wanted to remind you about, and we're right here. So on Wednesday, I'll remind you about the rest. So we're already behind schedule. I'm not too concerned. That's why I built in all those extra days. So we're going to sign off here because we actually are a little over time, and I apologize. I didn't want to stop in the middle of quadratics. So we'll pick this up on Wednesday. I'll give you sort of the remaining important stuff from pre-calc, and then we'll start diving into calculus. Now, I know that this was all just little tiny bits, kind of fast. That's what this first chapter is. I'm just giving you the highlights. If you were watching some of this today and were like, oh my God, I have no idea what you were talking about when it came to even, odd, blah, 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 go back and look that up, okay? Because we don't have the time to talk about pre-calculus because we need to do calculus. I'll still help you out as much as I can, right? But it kind of needs to be on you if there are things that I brought up today that you're like, oh my God, I don't remember. Okay, so we'll continue this on Wednesday. But other than that, it was good seeing everybody. So Mariola, the word of the day, I haven't decided if I'm going to do that yet. So I'm not going to do one today. For those of you who have no idea what that was, it was something I did last quarter to get people to watch the videos. I'll probably start doing it, but the first day you get it for free. All right. Anyway, all right, so I'm going to stop the recording